You are a masterpiece of adaptation, designed for a world that no longer exists. For most of human history, food wasn't guaranteed, it was uncertain, and if our ancestors became weak or confused after just a few hours without eating, we wouldn't be here. But today, we eat from sunrise to midnight, keeping our biological system permanently switched on and living in constant biological noise. So what happens when that noise finally stops? When you eat once and allow a deliberate 23-hour silence? In this video, we're going to step inside your body to see how that silence flips your metabolic master switch and reveals what your system was built to do. Please note that the video is for educational purposes only and not medical advice. The story begins at a very specific moment, the instant you take that final bite of your only meal for the day. In that moment, right inside your body, a city comes alive. As the meal digests, the silence ends and your body enters the absorptive state. In our metaphorical fat city, this is the busiest hour of the day. Glucose, the city's primary fuel, floods into the bloodstream like a fleet of cargo ships pulling into harbor all at once. And in response, your pancreas releases its most famous worker, insulin. In Fat City, insulin is the Dockmaster. It stands at the harbor with a megaphone, barking orders, directing traffic, and trying so hard to organize the chaos. Muscle and liver cells respond quickly, pulling glucose inside and storing it as glycogen, a short-term, rapidly accessible energy reserve. But that storage is limited. Once those warehouses are filled, excess energy is diverted elsewhere, sealed into long-term vaults as body fat. And here's the key point. As long as insulin remains elevated, those fat vaults stay locked. Not by accident, but by biological design. Insulin suppresses fat breakdown, preventing access to stored energy while fresh fuel is still arriving. In the ancestral world, this was an efficient survival strategy. Why tap into your reserves when fresh food is still flowing? But in the modern world where food is abundant and you eat constantly, insulin rarely falls and the Dockmaster never leaves. The fat reserves remain sealed, not because they aren't needed, but because the city is never quiet long enough to access them. During fasting, the silence doesn't arrive suddenly. It comes as a slow, well-calculated retreat. Over the next several hours, Fat City runs on what remains from the last delivery. Insulin stays present, not directing traffic, but more like finishing the paperwork. And as the glucose levels continue to drift downward, and almost all excess energy is accounted for, insulin steps away from the harbor. To keep operating, the city draws from its internal buffer, liver glycogen. This phase feels unremarkable. You're still alert and feel completely normal. But metabolically, something important has happened. For the first time today, no new fuel is arriving. As glycogen levels decline, a familiar sensation appears. The ghost of hunger. A hormone called Ghrelin rises, not because energy is gone, but because food is expected. For many people, this is usually the exit point. The stomach feels hollow and thoughts sharpen around food. But biologically, it is your system asking a question. Is more energy coming, or it's time to make that switch? If you eat now, insulin levels rise again, the Dockmaster clocks back in, and the question is never answered. But if the silence continues and liver glycogen levels continue to fall, something even more remarkable happens next. Your metabolic switch flips and fat metabolism begins to rise. Not at a single dramatic minute, but typically between 12 and 18 hours in healthy adults, as liver glycogen declines and insulin falls toward baseline. This pattern is not appropriate for everyone, particularly during pregnancy, advanced metabolic disease, underweight states, or in those with a history of disordered eating. And that drop in insulin levels changes the landscape, because insulin not only promotes fat storage, but it also suppresses lipolysis, keeping the fat reserves locked away. When insulin is elevated, the vault doors remain sealed, and when it falls low enough, those doors begin to unlock gradually. Inside your adipose tissue, enzymes like hormone-sensitive lipase begin to activate, and through a process called lipolysis, triglycerides, the long-stored dense energy reserves, are carefully broken down into fatty acids and glycerol. Fatty acids flow into the circulation, supplying energy to your muscle, heart, and other tissues. And for the first time in hours, the reserves you've been carrying, sometimes for years, are finally being accessed. Not because you are starving, but because the hormonal environment has changed, and that change unlocks a different fuel system. This gradual transition from glucose reliance toward greater fat utilization is what we call metabolic flexibility, a normal, well-described human fasting response. As the fast extends toward roughly 18 to 24 hours, fat metabolism is now well established in most healthy adults. Liver glycogen is largely depleted. Fatty acids are supplying much of the body's energy demand, and ketone production is beginning to rise. With insulin low and nutrient signaling reduced, the hormonal environment shifts. Growth hormone secretion, which often increases within the first 12 to 24 hours of fasting, becomes more pronounced. Its role is protective. It helps preserve lean tissue by reducing skeletal muscle breakdown as the body shifts toward fat as its main fuel source. Interestingly, growth hormone also stabilizes blood glucose production, ensuring the liver can continue generating essential glucose while the rest of the body shifts toward fat. Around this same time, growth pathways influenced by insulin and mTOR are quieter, and when growth signaling quiets, maintenance processes known as autophagy gain more room to operate. Autophagy, the cell's recycling system, is always active at baseline, but under fasting conditions, mechanistic evidence suggests the balance shifts toward greater cellular cleanup, with the strongest evidence for large increases in autophagy coming from animal models and longer fasting durations in humans. But reduced nutrient signaling and lower insulin levels are well-described signals that favor repair over growth. In Fat City, this looks like maintenance crews moving through the older neighborhoods. They identify damaged proteins that no longer fold properly and dismantle worn-out cellular parts. Even cells that have stopped dividing, known as senescent cells, are marked for cleanup. Nothing is wasted. The broken ones are cleared away and useful pieces are recycled by approximately 20 to 24 hours. Ketone levels have risen enough to begin contributing meaningfully to brain energy metabolism in many healthy adults. Most of your body is now running on fatty acids. The brain, however, still requires glucose, which is now being produced through gluconeogenesis in the liver and kidneys. In Fat City, it's like activating a secondary power source for the command center. The primary grid is still active, but it is no longer working alone. Ketones cross the blood-brain barrier efficiently and provide an additional steady fuel source for the brain. Some individuals in this phase experience a sense of calm or steady focus, not because fasting creates cognitive superpowers, but because blood glucose is being maintained within a stable range and fuel delivery is no longer tied to repeated meals. From a physiological and evolutionary standpoint, this is expected. When food is absent, the system shifts toward metabolic stability, ensuring that cognitive function can be maintained even in the absence of incoming fuel. Eventually you break the fast, the harbor reopens, and the silence finally ends. After a prolonged fasting period, particularly if liver glycogen has been substantially reduced, tissues are generally more insulin sensitive acutely. The loading ramps or the glucose receptors respond efficiently, and glucose is directed toward replenishment. This does not permanently reset metabolism, but in the short term, nutrient handling tends to be more responsive following a fasting interval. And here is the climax. What you bring into the harbor at this point really matters. Highly refined carbohydrates can produce a rapid rise in insulin, and insulin will again suppress lipolysis as it is designed to do. But a meal composed of protein, fats, and fiber produces a more moderated glycemic and insulin response. Fat City was never meant to be starved. It was meant to move in a rhythm of shipment, storage, silence, and release. Glucose isn't the enemy, and fat isn't a flaw. The problem is constancy. When the harbor never empties, the city never gets to engage the adaptations that kept it resilient. But here's where the story becomes more complicated. Some fat is designed primarily for storage, accumulating energy, and releasing it when needed. But not all fat behaves the same way. Some fat doesn't just store energy. They release inflammatory signals, alter insulin sensitivity, and send its contents straight to the liver through the portal vein, influencing the very organ that regulates your metabolism. In the next episode, we step inside that deeper district to expose the toxic tenant, the visceral belly fat that lives rent-free, damages the vital organs, and changes the rules of the city. If this video changed how you see fasting, let me know in the comments what stood out to you. And until next time, stay med-curious, stay healthy. See you soon.